The primary goal of descriptive statistics is to take large data sets and make them understandable. So when you're faced with a list of 1,000 numbers, it's very difficult to get any kind of useful information out of them. One of the ways that descriptive statistics tries to make sense out of that sort of situation is through what are called measures of central tendency. Now, that's just a fancy math way of saying that we're trying to find a number that somehow represents the middle of the data. As you'll see over the next several slides, there are a number of different ways that we can do that. Now, if you think back to high school geometry, you might remember learning about finding the midpoint of a segment. For example, if we have this segment from 2 to 11, we can find its midpoint by averaging the endpoints. For this segment, that would be 2 plus 11 divided by 2, or 5.5. Now, in statistics, this geometric type of middle is called the mid-range, and we find it the same way, by averaging the biggest and the smallest numbers in the data. So looking at this data set here, I'd like to find its mid-range, but you have to be careful. The first thing you should notice about the data values is that they aren't sorted. There are several of our central tendency measurements where you have to work with the data after it's been ordered. So the first thing you should always do is look at your data set and see whether it's sorted or not. Now, since this data set is small, even though it isn't sorted, it's still relatively easy for us to pick out the maximum value, that's 12, and the minimum value, 1. Now, if we put those numbers into our mid-range formula, we get that the mid-range of this data set is 12 plus 1 divided by 2, or 6.5. Now, the measure I want to talk about next is related to the mid-range in the sense that it's also trying to find a physical middle for the data. Now, I've got the same data set here, but when you're looking for the median, you absolutely have to sort the data first, and that's what I've done in the second list here. It's the same as the first one, but with the data sorted. Now, to find the median, what we do is look for the number that's in the exact middle of the data set. So what I'll do to find that is I'll start crossing off the numbers one at a time from the left and right sides. And you'll see that that leaves us with 6 as the number in the middle. So that makes 6 the median of the data. Now, there's one problem we can run into when we're looking for the median. If there isn't an odd number of numbers in the data, then there isn't going to be a number in the middle, like the 6 in the previous example. You can see that in the data that I've got here. If we do the crossing out that I did in the previous example, when we get to the middle, there's no number left. It would fit in here between the 6 and the 7. So when that happens, all you do is you take the average of the two numbers that are in the middle. For this data, those numbers would be the 6 and the 7. And if we average those numbers, we get 13 divided by 2, which is 6.5. Now, the next measure we need to think about is called the mode. The mode of the data set is the number that occurs the most often. So if you look at the data set here, all the numbers appear on the list once except for the 3. It occurs 3 times, which is more than any other number on the list. So it's going to be the mode of the data. Now, the mode is the middle of the data in the sense that it represents the point where the data is at its thickest or most concentrated. In mathematical terms, this is what we call density. So mathematically, we would think of the mode as being the value where the data is densest. One last measure, the mean, is the most commonly used statistical measurement along with standard deviation. To calculate the mean, you start by adding up all the data elements. Remember that that's what this sigma x part means. Remember that sigma is the mathematical symbol for add up all the values. So then you divide that number by the number of values in the data. So for our example, the sum of these 9 numbers, if you add them all up here, is 59. Then to get the mean, you divide that by 9 to get 6.56. What makes this measure so generally useful is that unlike the other measures, it uses every value in the data. So this means that unlike many of the other measures, changing any one of the values will always change the value of the mean, where this isn't necessarily true for the other measures. In the next lecture, we're going to compare the 3 most common measures, the mean, median, and mode, and look at some of their individual kind of weaknesses.